Welcome to Spaceverse, your portal to cosmic adventures. For years, we've been taught that the universe originated from the Big Bang, marking the moment everything we know came into being. But what if that's not the entire story? Nobel Prize-winning scientists, including Dr. Roger Penrose, argue that the Big Bang wasn't the beginning, but merely a chapter in a much larger cosmic narrative. Recent studies even suggest the possibility of a mirror universe existing beyond the Big Bang. Some scientists propose that an anti-universe operating in reverse time could help explain phenomena like dark matter and cosmic inflation. As of now, there is insufficient evidence to confirm this theory. Dr. Roger Penrose suggests that remnants of black holes from a previous universe might still be detectable in the microwave background of the current universe, offering evidence that there was a universe before ours. For centuries, this idea was purely theoretical, but recent groundbreaking discoveries from the James Webb Space Telescope are now providing scientific evidence to support it. The Webb telescope's recent findings challenge the Big Bang theory, with some experts believing that the images captured indicate a universe quite different from what we previously imagined. So, what exactly did the telescope uncover? It discovered a geometry known as hyperbolic geometry, a striking representation of infinity. This image, when used to think about space-time, suggests that the Big Bang was like one of those boundaries. It appears smooth and continuous, allowing for the possibility that the universe could extend beyond that region. Even though the image ends with a circular boundary, we can still imagine that space-time continues beyond it. The portion of the universe visible from Earth is known as the observable universe, which spans roughly 93 billion light-years. However, this is only a small part of the entire universe. It extends far beyond what we can see, containing even more galaxies and stars. While scientists believe the actual size of the universe may be infinite, our view is confined to what we can observe, as light from areas beyond this region hasn't had enough time to reach us. What's even more intriguing is that the observable universe depends on your location. An alien civilization in a distant galaxy would perceive a completely different version of the observable universe because their perspective would be unique to their position. Another fascinating aspect of the universe is that when we look deep into it, we are also looking back in time. The light from far-off stars and galaxies took billions of years to reach us, meaning we are observing them as they were in the distant past. While our theories about the local universe work well, they fall short when explaining the formation of galaxies and the growth of black holes in the early universe, especially as we look back toward the Dark Ages. It appears something strange occurred during this time, and our theories struggle to account for it. With the telescopes we have today, we can only observe up to a few hundred million years after the Big Bang. What we're observing is a galaxy formed just a few hundred million years after the Big Bang, yet it already contains a supermassive black hole at its core. This highlights the challenge of explaining how these objects formed. There was not enough time between the Big Bang and the creation of these early galaxies, which already contained supermassive black holes at their centers. For instance, scientists have recently discovered massive black holes at the centers of galaxies that formed just a few million years after the Big Bang. Scientists were astonished because it seemed impossible for such black holes to have formed so early in the universe. A group of astronomers found a low-mass supermassive black hole at the center of a galaxy, consuming matter at an extraordinary rate, 40 times faster than the theoretical limit. Additionally, these early black holes were found to be growing with 80 to 100% efficiency, a phenomenon that was previously thought to be only theoretical. Astrophysicist Sophie Kadmani from the University of Cambridge offered a unique perspective on the origin of these early black holes. When asked if they could have formed from primordial black holes existing before the Big Bang, she provided an interesting explanation. Kadmani suggested that if black holes grew quickly and efficiently in the early universe, small, lightweight seed black holes could have had enough time to evolve into the giant black holes observed today. This possibility implies that primordial black holes could indeed explain the formation of these early cosmic giants. This discovery opens the door to the idea that the universe may have existed before the Big Bang. Further supporting this theory, the James Webb Telescope recently made a surprising finding in the early universe. For some time now, scientists have been uncovering unusual galaxies formed just a few billion years after the Big Bang. And not only galaxies. As the Webb telescope delves deeper into the early universe, it is also detecting unexpectedly large black holes, which completely challenge our current understanding. Scientists have revealed that there is no way these objects could have formed so early in the universe. While our own galaxy has developed over 13.6 billion years, scientists have surprisingly discovered a galaxy that is far more massive and structured than ours, within the first billion years after the Big Bang. A recent discovery involved 3 ultramassive galaxies formed near the beginning of time, which seems to contradict the idea that the first galaxies must have been built in a slow, inefficient manner. These ancient, colossal structures have been nicknamed red monsters because their high dust content gives them an intensely red appearance in images from the Webb telescope. Steen Witz, an astronomer from the University of Bath in the UK, commented that the galaxies, each as large as the Milky Way, are puzzling because most scientific models of galaxy evolution suggest the processes would have been slow and inefficient. Yet these red monsters appear to have bypassed many of these expected challenges. This study adds to the growing body of evidence suggesting that cosmologists still have much to learn about galaxies. Last month, a separate team of scientists reported the discovery of Rebels 5, a galaxy that existed when the universe was only 700 million years old, yet bears a striking resemblance to the Milky Way. This discovery significantly challenges our current theories of galaxy evolution. It suggests that if our theories are correct, either these early galaxies existed before the Big Bang, or something unusual occurred just after the Big Bang that dramatically accelerated galaxy evolution in the early universe. Roger Penrose proposes that the universe undergoes endless cycles of creation and destruction. In this theory, each universe ends in a quiet state where black holes gradually disappear over vast periods of time. However, the energy from a dying universe could trigger the Big Bang of a new one. In essence, our universe could be the latest in a series of universes, with remnants from the previous one influencing its creation. The discovery of massive black holes raises intriguing questions about their origin. Scientists speculate that these black holes might have come from even older primordial black holes, which could have existed before the Big Bang itself. This is a captivating concept because the Big Bang is typically considered the beginning of everything, including time and space. If these black holes existed before the Big Bang, it implies that there may have been events in the universe's history that we don't fully understand yet. These ideas challenge our conventional understanding of the cosmos and suggest that the universe is much more complex and mysterious than we currently realize. And that's it. Thanks for tuning in to Spaceverse. Today, we delved into some of the universe's greatest mysteries, from the possibility of mirror universes and primordial black holes to groundbreaking discoveries that challenge our understanding of the Big Bang. The more we learn, the more we realize how much there is still to discover. Keep questioning, stay curious, and remember, the universe is far more complex and fascinating than we can imagine. Until next time, keep exploring the cosmos.